Okay, today is day 2 of RV solar install on our new fifth wheel. I got the batteries and everything installed in the trailer on the last one, which was 2 days ago now, and today is time to get back in here and install the inverter. So I've just gone ahead and laid a piece of 1/4-inch plywood across the batteries and my jacket over top of that, just to prevent me from dropping anything onto the tops of the batteries that might cause one of them to arc or short circuit. And I've just been trying to think about how I'm going to do this. The inverter is going to go in this location here, as high as I can get it, and I'm thinking the inverter weighs like a considerable amount, so I think I might do a combination of maybe strapping it to this cross member here, while also running bolts straight through this wall with washers and stuff, and actually bolting it in place. There's 6 anchor points on the inverter to do that, just to make sure that while we're bouncing down the road, that there's no possible way that this thing can pull itself off of here. I don't know how much the inverter weighs. It weighs a considerable amount. I've just had bicep tendon reattachment surgery, so it's far more than I can lift. So I'm kind of come up with an idea that I'm going to run a couple of tie straps up and over this bar, and then just kind of ratchet it into place. I've kind of come up with a similar system where I'm kind of have it over my shoulder as a sling to kind of lift the one side of it off of my neck, and then I can still use my right arm just fine. Once I have it in place, it might actually be nice to have it held there. Then I'll start drilling through the wall and running the bolts through. Well, it looks weird, but I'd say that ended up working okay. And the best part is that I've got something to kind of hold it there while I start sending screws. Okay, there it is. 6 bolts, and then I also, just to make it double secure while I was trying to get the bolts through, I put some wood screws in there as well, which I'll probably just leave them. It's not going to hurt to have them, but 3 along the bottom, 3 along the top, all the way through that wall to the back. And I think it looks pretty good there. So now the only thing that we have to do is get it all hooked up and working. So I think the first thing I'm going to do before getting into the battery side of this is actually run the AC for the trailer itself. And because the breaker panel actually isn't too far from here, in the past we've done an extension cord and ran that back to the shore power, but in the case of this one, I think probably what I'm going to do is I'm just going to disconnect the shore power, because the solar system that we have is more than enough to handle everything that we need, and then I'll just tie it directly into the panel, and then we will use the charger portion of this as our shore power if ever the solar isn't enough. Okay, so we've started to pull some wire here. There's just on the other side of this wall actually is already a hole, because the brain for the self-leveling landing gear is on the other side of this, so I'm just gonna steal that hole to pull my wire through, and then I actually discovered this by accident because I pulled this cover off thinking that I was going to maybe put some of the solar equipment in here. There isn't a whole bunch of room though, I discovered, and also there's a lot of water lines going through here, so my concern was if anything ever happened to one of those, and I'm sure that could very easily happen, that now there's a water faucet spraying all over our electrical stuff. So, but as it turns out though, this giant hole here leads to the inside of the trailer and the back side of where the breaker panel is. So I should be able to pull wire from that corner up and over, and then drop it down through here, and then go straight right into the main power on the back of the panel. Our trailer is a 50 amp connection. There's obviously nothing that runs on 240 volts, so it's just two legs of 120, that one that runs half the breaker panel and the other half. And I don't have any 3 conductor wire, but I do have some 15 amp single hot wire. So what I'm going to do is I'm just going to run 2 of them over and hook into it that way. The inverter that we have is only capable of putting out 30 amps anyways, and those cables are capable of doing 20 apiece. So okay, so this is the other side of that big hole, from the inside of the storage compartment there. I've already pulled out the 2 drawers that are above this, and I'm just about to pull the breaker. I've already pulled the door off of the front. I'm just going to shut the power off and pull this out so that I can get a better look at hooking up to the back of this. Okay, so I've got the shore power pulled off, and then I've just got it sort of coiled back up and taped off, and hidden back on the other side of that big hole. And then rather than running the 15 amp sort of household stuff, when we got this trailer, they actually provided us with another 50 amp shore power cord. So now we actually have, I think we actually have 3 of these now. So like what I've done is it's plenty long enough to get where I need to go. So I've just cut the end off, and I'm just gonna use this instead, and I'll probably end up having to drill a second hole through the compartment to get it up to the front. But that way this cable is more than up to the job of doing anything that we want to do. Okay, there we go. We got our 50 amp main wired up on the panel end, and now I'm just going to go to the other side of this and start wiring the inverter end of it. The batteries still are not in the equation yet, so this whole thing is still dead. Okay, so there's the other side of that giant cable coming through into the storage compartment, and I just need to follow along with this one here. I'll tag it to that, and then I'll do it on the next one over, and then I'll hole saw a new hole about in this area here, poke it through, and then that's also this. You can see these are the backs of the bolts that I use to install the inverter, and that'll drop that right in front of where we need to hook up. All right, so I've got things suspended, and I've got a hole through the panel here, and it's dropped into the front compartment and actually connected to the inverter already. Simultaneously, I decided to run the communication cable for this inverter. Has a remote that will install inside the fifth wheel somewhere, so I've got that coming through the same run, and I'll pull that through into the fifth wheel later on once we get the power working. So there's our power coming through the wall. I've got it on a disconnect, so I can shut the AC leg totally down from here to the breaker, as well as there's a breaker in the main breaker as well. And then I've just got this wired in temporarily, because once we get the batteries hooked up here in a minute, we should be able to test everything to make sure that it's all running properly, which is what I'm going to do right now. Okay, moment of truth. Test number 1, hopefully the only one we need. The inverter is now connected to the batteries. So let's just go ahead and switch it on. And it's saying that the AC is abnormal, which we would expect, because although I do have this connected right now for a different test than the actual inverter itself, producing power off the batteries, it isn't actually plugged into anything. So let's go ahead and turn on the disconnect that I put in, and then we'll just run inside and see if we got anything. Turn on the main breaker. Oh, I just heard the microwave beep, so that's good news. So our control panel is firing up. So we got lights. So the fridge is running. So everything seems pretty good. So technically at this stage we could use everything and we would be good to go. However, everything is running off the converter right now. So if I flick that off, we should lose all of our 12 volt now. Yeah, so no lights. Would have lost the fridge during that time, because it's a 12 volt fridge. And so the question, I guess, would be, well, what's the big deal with that? I guess the big deal with that is that mainly I just want the option to be able to turn the inverter off. So at nighttime, for example, we have this control panel here that's going to actually be inside, and the ability to turn it on and off will be pretty simple, because we won't have to go outside anymore like we used to before with our older systems that we had. And I just want to be able to turn it off and not have to rely exclusively on the converter to handle all the 12 volt stuff. So I have a bunch of other equipment that needs to still be installed. We in the front there, the shunts have to go in right now. I've just got the inverter wired directly to the batteries, but so we need to fuse it. We need to put the shunt in. But then also I have a 24 volt to 12 volt step down converter that is going to go in there as well, and then the batteries will connect to that, and then coming out of that we'll have 12 volts connecting to the trailer. So what this will do for us now is that even if the inverter is shut off, or if there is a problem with the inverter for some reason, all of our 12 volt things like our lights and fridge and the things that you would normally only have if you were boondocking will still continue to work. So far so good. Okay, we're making progress here. I've got the batteries re-disconnected again after just testing to make sure that everything was working okay. I have installed the locations for the shunt and the fuse. So this is our positive fuse here, and then I've done something a little bit different, which is that I actually have two shunts. So I have this one here, which is a Victron, or sorry, a Renogy one, and then I have the smart shunt over here, which is a Victron. I'm going to see what happens when you install them both. I'm assuming it'll work fine. But I kind of wanted to have both because this one, the thing that I like about it is that it connects to your phone by Bluetooth so that you can have a look and see what's going on with your batteries in pretty good detail on your phone. But then this one has a control panel that can just stay stationary inside of here somewhere, so that when you actually open up this compartment, I can have it displayed. I might actually strap it maybe to this bar up above here, so that we can just see at a glance how things are operating from there. So I've made my first short little cable out of the back of the inverter and into the first location on the shunt number 1. So I'm just going to carry on making cables until I find my way back to the battery connections again. All hooked up. I've got all my interconnects joining the 2 shunts together. The 2 shunts are working fine. There's the renogy one up top that I just wanted to have in here so that I can just have a quick look and see what's going on. And then I've also got the Victron one that I still need to pair to my phone, but everything appears to be working just fine. I've got both of the shunts do require positive power in order to operate, so I've got them both connected to the positive fuse that I just wired here in the center of them both. Batteries are hooked back up again, just about ready to hook the solar panels back up to it again and see if it all runs. Okay, so I'm just cleaning up in here a little bit, moving the solar controller from where it was in this location to just down under the inverter here, moving the breakers and rewiring all that as well. This location here is going to be where the 24 volt to 12 volt down converter is going to go, and then finally the battery balancer will go in there. So I'm just going to keep putting things together, and we're on the home stretch for the charging side of things anyways. Okay, so we got everything all cleaned up. Still leaving this location open for the 24 to 12 volt step down. And now I'm just about to put the Victron battery balancer in over here. Get that all wired up, and then that probably is maybe going to be enough for today. Okay, everything is ready to go. It's time to get everything fired up and see what we got here. So I've got the battery balancer in now, and it's all connected. I didn't spend a whole bunch of time explaining how this one went together, because I did make a video on how this works a couple ago. So if you're curious about what this does and how it works, I did make a video about it. But everything on the 24 volt, which is all this, is now working. I hope it's working. I still have the 12 volt side, which is all here, that isn't installed yet, but at least for now we should be able to see if the AC is working, and AC current as well as AC like as in air conditioning. So let's see here. So I've got we'll fire up the breaker for the batteries and the solar panels. So we'll just give those a minute. Little blue light here. There we go. It's just turned on solid. So the solar panels have just reconnected. This is the kill switch that is for the 50 amp service AC side going into the trailer. So we'll just fire that up, and we will head inside and see if we have any electricity.
All right.
Okay, so there's still some more work to do. This is the remote for the inverter that is going to get mounted somewhere, I'm not sure, but at any rate, this is how we are going to turn it on and off. So, welcome. It's a very friendly inverter. So, output load bypass. So that just means that there's nothing in the way of electricity from the house or anywhere else it's plugged in. We're on batteries alone right now. So then now I'll just turn on the main breaker for the whole panel. So there goes the microwave
on.
Yeah, so the converter is on. So even though the 12-volt system isn't working yet currently, we should still be able to use the lights and everything as long as the converter is on, which seems to be working just fine. The one control touchscreen is just firing back up again here. So far so good. I have the 12 volt and the 24 volt systems separate. So we are going to keep the 12 volt separate so that if you were boondocking and you only had the 12 volt side to work with, that's your slides, it's your lights, it's your what makes the furnace run, it's all that stuff. So when I want to keep those things separate, because if for some and not use the converter the whole time to produce 12 volt, because if the inverter goes south or something happens to any of the components for the actual inverter side, we have nothing. So I still want them to be separate so that when hopefully that never happens, but if it does, we still have the opportunity to run the 12 volt. Plus we also have the opportunity to shut this off at night so that we're not using too much battery power in the evening when there's no sun. But anyways, the main event, well, there's going to have to be a part 2.5 because I've still got the 12 volt side to finish. But the main event of the AC side, which is finished as of right now, is can you run your air conditioner on solar and inverted power? So let's give it a try.
It works.
So that's the fan. There it goes.
You did it.
Okay, so as it turns out, on solar power and batteries, you can run you can run one air conditioner anyways. I wouldn't expect that both of the air conditioners would run off of this inverter because it is a 3,000 watt inverter. It's not, I mean it's a 50 amp trailer, but I mean the way that the inverter is set up and hooked up in here, it's not really a 50 amp service coming out of that. So we can try it someday, but I wouldn't expect that it would. But this air conditioner is the one that was important to us because that's the one that supplies air to our bedroom, which is where you want your air conditioner to work if you're not plugged into power, so that you can sleep at night. As far as how much power is that using? Currently, according to the sungold here, the output load is about 51%. The batteries are still at 26.2. There's no input AC whatsoever at all, so this is literally running off of just the inverted system alone. And this doesn't really tell you how long you've got before you're out of power, but I mean this is our battery level here, which is 4 bars full. This voltage stays relatively consistent throughout. By the time we get into probably the low 25s, I guess, would be the time where I would want to be going outside to see how this is running. The Victron shunt, I don't know if it'll work from here. Oh, it will. Yeah, so 91% is where the batteries are at as of now. And the amount of time that we have remaining on the air conditioner running at the moment, which I had set the thermostat to as low as a temperature as it would let me so that it would run without interruption. But it's telling me that I'm going to be able to do that for another 7 hours and almost 8 hours with the little bit of solar that we still have coming in. It's it's pretty much, the sun is pretty much down for the day, so we're not really making a whole bunch of power, but 7 hours 40 minutes ish, whatever, on just the batteries alone. I mean, I feel like that's pretty impressive. So can you run your air conditioner on solar? Well, depending on how you put it together, yes you can.